The purpose of this experiment is to measure the reaction order and rate constant of a reaction involving phenolphthalein. To do this, we're going to use a spectrometer to monitor the reactant concentration. We can do this because our reactant is colored. So if you look here, I'm just going to add a couple drops. You can see our reaction is pink. Our reactant is pink. So the amount of light that our spectrometer will measure as our sample is absorbing is going to be directly proportional to the concentration of our reactant. So if we measure the absorbance of our sample as a function of time, we'll be able to both confirm whether or not our reaction is first order and also measure the rate constant for this reaction. As you can see, I've already made up all of the samples as described in the procedure. The first thing that we need to do is calibrate our spectrometer. So to do that, we're going to get some of our calibration solution, marked C, and we're going to fill our cuvette till it's about 2/3 to 3/4 full. And we cap it. And the important thing to note about these cuvettes is that there is a clear side and there is a side that has lines on it. So you want to hold the cuvette so that your fingers are always on the side with the lines. And this side has to remain completely smudge free. So you can clean it if you have to. And if you look inside the spectrometer, you can see right there on the left wall, there's a light beam that passes through the spectrometer from here to here. So when you insert the cuvette, you want to insert it so that the clear sides of the wall, so right now you're looking at the line side, so the clear sides is what the light beam is passing through. So I'm going to insert my cuvette like that. So now that our cuvette is inserted inside the spectrometer, you have to make sure you're on this Analyze Solution screen, and you need to perform a calibration. So you first perform a dark calibration. So you click Calibrate Dark. That just turns off the light inside the instrument and blanks out any room light. And then you perform a light calibration. So you click this button. And what that does is if the solvent itself is absorbing any light, it's just going to blank that out. So now if I press record and start measuring absorbance, you can see there's a completely flat line here. So you're probably not seeing anything, and that's good. What we don't want to see is any peaks from our solvent absorbing any light. So I'm going to press stop. It's going to delete that. All right, so now I'm going to remove the cuvette, and we need to add some of our phenolphthalein solution, because the next step is to figure out exactly which absorbance, which wavelength we should be using for our spectrometer. So I just shake it, I insert it in the correct way, and I hit the record button. And then I'm also going to use my scale to fit button just to make this a little bit easier to see. And you can see that what we have is a nice peak. Our solution is absorbing light in the wavelengths of about 500 to 600 nanometers. I press stop. And then what I need to do is determine what wavelength this is right here where we have the maximum absorbance. So we have an add coordinates tool, and I can drag that over, and I can even nudge to the left or the right. And what I'm looking for is I'm watching this number, 0.705 right now, and I want to find out what wavelength is this absorbance a maximum. So I think it's actually to the left just a little bit. Yeah, here we have 0.714. That's the biggest number I've seen. Yes, so 0.714 is our highest absorbance. So that means we want to use this wavelength of 557 nanometers. So to tell the spectrometer to do that, all we have to do is hit this check button. So now we're ready to analyze our reaction solution as a function of time. So we're going to remove the calibration solution. To our next cuvette, we will add solution number 1. So again, fill the cuvette till it's about 2/3 to 3/4 full. To this you'll be adding some phenolphthalein. The directions say 1 to 2 drops. Put the lid on, mix it, and again, insert it with the correct orientation. Now what you need to do is go to the Analyze the Solution as a Function of Time button. So we have a new screen. You're going to hit play. This little rainbow icon, this just tells you that you're using that wavelength of 557 nanometers that you set. So we're going to press play. And what we want to see is if our initial absorbance is above 0.5. And you can see we are not. We're actually at 0.43. So we're just going to take this out. We're going to add just a tad more phenolphthalein. Put it back in. I'm actually going to press stop here to delete this run. Put our new solution back in, press record, and this time we should be above 0.5. Yes, so we're at an absorbance of 0.6. So at this point, you are going to measure, just follow this reaction as a function of time until your absorbance falls below 0.15. When it gets below 0.15, then we can hit the stop button. So now we will wait and watch and see what happens. So now that our absorbance has fallen to 0.15, I will press stop. And at this point, what we want to do is we want to change the y-axis units to the natural log of absorbance instead of absorbance. So to do that, I use this little button that looks like a calculator. And you see that's 1 over absorbance, which isn't a straight line. But now we have natural log of absorbance. And what you can see is that in this region from 200 to 400 seconds, once we get out here, this line looks pretty straight. It's pretty linear. And so what that indicates is that in this region, anyhow, a reaction is a first order reaction. So at this point, what I want to do is use my selection tool here to highlight the absorbances which range from 0.4 to 0.15. And on a natural log scale, that's from about negative 0.9 to negative 1.9, which is down here. And then I will use my linear fit button. I have to move this out of my way to show that best fit line. So now what I want to do is I want to record the value of that slope in my notebook. So that is m, so it's negative 0.00315. Okay. So the only other thing you have to do is you need to take a screenshot of this page, and you're going to use the sharing button to either email it to yourself if you are on an iPad, or you will save it to your computer if you are on a desktop.